Problem Solving and Program Design Lesson 1. The objectives are as follows. Outline the 5 steps to problem solving. Describe functional decomposition. Create a defining diagram or IPO chart. Use an IPO chart to define or decompose a problem. Create a pseudocode algorithm for a given problem. Create a flowchart algorithm for a given problem. And create a trace table to test your algorithm. Problem solving techniques are used in many different areas, including engineering, mathematics, computer science, and while there may be different models and tools available, one common methodology is functional decomposition. Simply put, functional decomposition is the breaking up of large complex problems into smaller, more manageable components in order to solve it. Our focus will be on solving the kinds of problems that we can write a program or software to solve. Before writing a program, one needs to develop an algorithm to solve it. So what is an algorithm? An algorithm is a sequence of very specific step-by-step instructions that will be used as a template for developing a computer program. Algorithms must be written in a standard format so that it can be implemented by programmers in any programming language. In a subsequent lesson, I will talk about different programming languages. Creating software or writing a program starts with the breaking up of the problem into 2 distinct phases: the algorithm phase and the implementation phase. We will first look at the algorithm phase. In the algorithm phase, there are 5 general steps. These are: define the problem, propose and evaluate solutions, select the most reasonable solution, design an algorithm, and test the algorithm. Now we will focus on each one of those steps in the algorithm phase in greater detail. So let's focus on step 1 of the algorithm phase. Define the problem. To define the problem is decomposed into inputs, processing, and outputs. And to help us do that, we use a tool called a defining diagram or an IPO chart, which looks like what you see on the screen in front of you. Now, in order to understand how an IPO chart is used, we'll have to use an example. The following example will be referred to as our problem, or problem statement, or our problem definition. The term problem definition will not come up at this level, but will come up at a more advanced level, such as a software engineering course. So let's look at the problem. Write a program to enter 3 numbers, find the sum of those numbers, and print the sum. This is a clearly defined problem statement or problem definition. However, this problem needs to be further defined using an IPO chart. This is step 1 of the algorithm development phase. Here we pay attention to the verbs in the problem statement and try to determine which of the verbs can be described as input words, output words, or processing words. Where do you think the words go in the IPO chart? At this point, you can pause the video and try it for yourself. Congratulations. If this is what you came up with, then you are on the right track. So, as you can see, we highlight the words enter, find, and print. And where would these words go in the IPO chart below? You are right if you said enter for input, find for processing, and print for output. The next thing you have to do is to determine what you have to enter, find, and print. And to do that, you need to consider variables. You have to identify an input variable to represent the number that you have to enter. You need to determine what operation is required to get the desired result. And you need to determine what variable is going to be used to represent the output or the data that is needed to be printed. If you need a deeper understanding of variables, then in a subsequent lesson, I will be talking about variables, constants, and operators. For this example, we will use the following variables. num1 for the first input variable, num2 for the second input variable, and num3 for the third input variable. We will then use sum for the processing and output variables. num1, num2, num3, sum, print sum. So in your IPO chart, this is what you should see. Enter num1, num2, num3, find sum, print sum. Step 1 of the algorithm phase is now complete. But as you can see from the IPO chart, we seem to already have the most optimal solution to this problem. So we can ignore steps 2 and 3. However, steps 2 and 3 will be applicable when multiple solutions present themselves. And depending on the size of the problem, choosing the right solution may require a feasibility study, which you will learn more about in more advanced software engineering courses. However, we'll jump straight to step 4, where we'll develop our algorithm. In order to do that, you need to understand a little about the structure of algorithms. There are two types of algorithms: pseudocode algorithms and flowchart algorithms. So let's examine pseudocode algorithms first. It's called pseudocode algorithm because it resembles or looks like programming code without the specific syntax of any programming language, but with enough programming structure so that it can be implemented in any programming language. Pseudocode algorithms are written using short English-like statements and indented to make it easier to read and understand. Pseudocode algorithms always begin with the word begin and end with the word end, and uses the word input or enter to signify input variables, and the word output or print to display to signify output variables. Let's look at our example to take the problem from IPO to pseudocode algorithm. Okay, so let's create a pseudocode algorithm from the IPO chart there. So our pseudocode algorithm would start with the word begin. Then you will simply enter the information directly from the IPO chart, starting with input. So you put your input statements, input num1, num2, and num3. There's no word for processing, simply put the information from the processing column into the pseudocode algorithm. Output sum, and that is your pseudocode algorithm for the example. Right, now that you know how to create a basic pseudocode algorithm, let's look at how we can create a flowchart algorithm using the same solution. First, you need to know the symbols used in creating flowchart algorithms. These are as follows. The oval, which is referred to as the start or stop. This translates to the begin or end in the pseudocode algorithm. The next symbol is the parallelogram, which represents input or output. The next symbol is the rectangle, which contains processing statements. Next is the rhombus, which represents decisions. And finally, the arrow, which shows the directional flow of your algorithm. I will now show you an example of how the flowchart algorithm is used to represent the solution instead of the pseudocode algorithm. So this is the existing pseudocode algorithm that we created earlier. We now create a flowchart algorithm to represent the same solution. So you see the flowchart algorithm has the same information as the pseudocode algorithm, just using graphical representation. Now you can pause this video and see if the pseudocode algorithm that you created earlier on your own can be used to create a flowchart algorithm. See you in a bit. Now that you know how to create a basic algorithm, we look at the fifth and final step in the algorithm phase, and that is the testing of the algorithm. To do this, we need to construct what is called a trace table. A trace table uses as its column headings the variables that are used in the algorithm, and sample data is entered as values to test the logic of the algorithm and to ensure that the desired results are obtained. Let's use the algorithm that we've created earlier to create a trace table. So this is the pseudocode algorithm we had earlier, and we identify the variables from the algorithm. And we place the variables as column headings. Then we populate the table with sample data. Now you try creating a trace table to test the algorithm that you created earlier.